You've joined the online class, Bharat? Okay. Aradhana, you take care of the attendance for till Bharat joins. Moving to moving to the class where I have stopped. So in the last class, I was discussing about the functions. Uh, and going forward, we pretty much understood about arguments, parameters. Even arguments are considered as actual arguments. Parameters are the formal parameters, or even these are called formal parameters of formal arguments. Arguments are called actual arguments, actual parameters. That naming conventions are there, but I will stick to arguments and parameters. All right. So we have seen like how exactly the values are being passed and able to utilize at the function levels. The values are being passed from caller function to callee function. So in this case, in this example which I have taken, probably in this uh, here, this line print twice is it's a line where it will call this function. So here it is the caller function, which is at main level. Main level means at command prompt level. This is the callee function, which takes care of only one input to this. Here, before passing this input, this expression is evaluated, and whatever the value it comes, the final output of this expression will be passed to the variable data, and this data variable is local to that function. And we did see that about cat. I tried to print outside. I got error saying that it is not defined. So any doubts, try to put a message over here. I can quickly show in the Python by executing the programs. So these things we all seen, and also we have understood how to read values from the keyboard terminal using the input inbuilt command. And in Python 2, it was raw underscore input. That's the function name. Now in Python 3, I hope all students have installed Python, and that is about version 3 and above. I'm using 3.10, 3.10. Probably any version 3 and above is fine. So whenever we are using 3 and above, it is input. But in case if you are seeing any of the code which is used in Python, to make sure that it is raw input rather than just input. So some slight variations are there. I'm not touching at detail at Python 2 because it is download uh, not so compatible. So I'm moving with the Python 3. So in the last class, I was explaining about before going to modulus operator, I explained about floor, especially floor, and how to get that quotient rather than remainder using double slash. It's called just it is it is called floor division rather than floor. Floor is something else, mathematical operation. Here it is with respect to division, it will go to floor. It will take the quotient part. Any doubts with respect to floor and how to get the remainder of that particular operation to what all the calculation we have to do to get that remainder. So instead, we can just go with modulus operator to get the direct remainder in one go. All right. So this is the pretty much calculating on the fly what is the left out part, and again computing with the whole thing to get the remainder. And if I just use the modulus operator, it is 60. So those who have not joined in the previous class and they have joined today, minutes is a variable having a value 105, and hours is having a value of say uh, 1 1, because minutes is 105, and by double slash 60 will give the actual value rather than the reminder part. But if I do that minutes by slash by 60, we'll get 1.75 with this 7.5 being a reminder. It is expressed in terms of minutes. In terms of minutes, 1.105 is expressed in terms of hours. If I want to say, it is 1.75 hours. 75 hours is 0.75 hours is expressed in hours rather than minutes. If I want to express in minutes, then 0.75 into 60 will get 45 minutes. That is the leftover part. That's the reminder part. So doing that instead, I can just go and do minutes modulus 60. I will directly get the 45 reminder. So that's the advantage of modulus operator. And it's the same thing for C also. The modulus operator is more useful than it seems. For example, when we want to check whether one number is divisible by the another, if x modulus y, if x is say 11 and modulus y is 2, so 11 is a prime number. It is divisible by 1 or by itself, right? So in that case, if any remainder present or not, we can make use of such things using modulus operator. So they are very handy operators which comes in multiple situations. Also, we can extract the rightmost digits or digits from a number. If I have a number 1029, so I want to extract the last digit, I can just do modulus 10. I will get the 9. 1029 modulus 10, I will get 9. If I want to extract two digits, on base 10, then that the whole number 1029 modulus 100, I will get 29, that last two part. So such things, modulus operator becomes handy for us. So again, there is a one quick comparison. When if we are using Python 2, the division slash works differently. The division operator in this case, both operands are integer. It just gives one output, because minutes is also what is integer? Whole number, no decimal number, no decimal value. 105 slash 60 both the operands are integer. Then it gives just one like this. So automatically floor division is coming into picture in Python 2, but in Python 3 it is different. We have separate operator for that. That is double slash floor division. Okay, and blocks. These are one of the structural blocks to build the programs. We might many a times we might come across making a checks like whether it is if it's true or false, things like that. So such expressions and taking decision whether if it is true what needs to be done, if it is not then what needs to be done, these are all called conditional blocks. So to build an expression, to get that evaluated to true or false, we might require a lot of operators and the expression details, operands, operators and things like that. We'll quickly see few of the example. So the first operator is double equal to. It is exactly works same as in C, but however, here in C we can't do with respect to the strings. Here we can easily do string comparison with double equal to. So for being at at integer level, 5 equal to double equal to 5, it will give the output as true. And 5 double equal to 6, it is not equal. It is a comparison operator. It is a comparison operator. It evaluates to either true or false. What is true? True is a Boolean. It's a Boolean value. It is not a string here. So whatever it is, type. Type is an inbuilt function or built-in function which takes any value and it will tell what type it belongs to. So the output it got as class belonging to Boolean. In many of your curriculum, you might have come across Boolean values 0 or 1. 0, 1, true, false are one and the same in programming when it is Boolean. In C also, if we calculate something like this, it will evaluate to 1 explicitly as 1, that is considered as true. And this will be evaluated to 0 in C, it is considered as false. Same thing, type, say, P should be a capital P. True, in the true case, it should be capital. Otherwise, if I write small, the color changes and it is not a part of keyword. Okay, the small, it says probably a string. Okay, type. It didn't understand. Did you mean true? It is asking. So what I meant is you have to mention the capital T in that case. Okay. And along with double equal to, there are few more conditional operators such as not equal to, greater than, less than, greater than or equal to, less than or equal to. It is similarly the way in C it works. I'm just comparing with C because we have something base to compare. So something extra in Python it is happening, I will explicitly mention it is not equal to as C. And there is no as such then like equal to, less than, equal to, greater than symbols. I will repeat, in Python programming, these two operators, greater than or equal to greater than, they are both different things. And this is the valid thing and this is the invalid thing. It doesn't understand if we write something like x equal to greater than y, it throws error. But if we write x greater than or equal to y, it is a valid thing. So I request all the students who are joining late, class starts at 1:30, try to be there with 1-2 minutes, at max of 1-2 minutes, right? And few of the programming languages, not C, Python programming, not either Python programming or C or C++ or even Java, some other functional programming languages are there. These things are allowed. These things are allowed. So that's why I explicitly have put these things are not part of Python programming. Any doubts, students, regarding conditional, especially Boolean expression? So if you have any such doubts, please put forward. Okay, moving on to, so in conditional, there are Boolean expressions, there are logical operations. They ultimately they provide us after evaluating, give us the output true or false. So I'm just highlighting about the possible expression, then I will move to the condition blocks, if, else, and things like that. Okay, before that, we need to understand what can be written inside that if condition. Some Boolean expression, things like that, it can be written. So that's why we saw the operators, Boolean operators, especially Boolean expressions where operators are coming into picture. Not these are all not Boolean operators, but they ultimately evaluate to Boolean value. Next is logical operators. There are three logical operators, and, or, and not. I don't have to explicitly mention. You guys are experts in and, or, and not. These are exactly like gates. So if two values are set to be true, then it is output is true. Otherwise, not. For and, or any one value is true, then it has to be the output it evaluates to true. Otherwise, if both are false, then only it is false. Not is just negates. Okay, so quick example, if x is greater than 0 and x is less than 10. It evaluates to true only if x value is in between 0 to 10, which is, uh, excluding the ranges if any x value is within 0 to 10, means 1 to 9 any value, then it is evaluates to true. That's how the AND comes. It is simple AND. In C we used to write which symbol? Anyone? In C which symbol we used to write for AND, logical AND operator? Correct. Exactly. And for OR, anyone remembers? For AND it is double ampersand. Ganesh is right. And for OR it says exclamatory, something like this. Ansab Aslam is right. Two pipes. In C it is ampersand and two pipes, right? So in Python it is pretty simple. And is and, or is or. They are keywords. So if I write anything, and is a keyword, see color changes. So 10 is less than 12 and 10 is greater than 9. It turns out to be evaluates to true. Simple. And is a keyword here. And the next example for OR I have taken is n modulus 2. It will give out a reminder, and if it is 0, which is divisible by 2, and which is divisible by 3, if the remainder is 0, any one is true, then we can say that the number is divisible by either 2 or 3. Simple example. Finally, the NOT operator negates a Boolean expression. So, not of x greater than y is true, then it becomes false. If it becomes false, x and this evaluates to true, means the not of true is false. Simple. So, and one more interesting thing is, strictly speaking, the operands of the logical operator should be Boolean expression. But in Python, it is not very strict. In C and all, if I'm using a logical operator, both the operands should be in terms of Boolean, right? In terms of Boolean, this it can be an expression, and that expression will evaluates to one of the Boolean value, either true or false. But in Python, it is not very strict. Even any non-zero number is interpreted as true. Since this is a quick example which I have taken. If I want to check 1 and true, it gives me an output of true. 1 is considered as true here. True and true is true. If I give 0 and true, it gives me is it doesn't give me the false, it gives me the 0 output. Any positive number is treated as true. All right. So this is one, it is not very strict when it comes to Python, when it comes to evaluating true value. So now we will see about conditional execution, means conditional blocks, structural blocks. Conditional blocks or selective blocks, they're all one and the same. When we try to build our programs, there are so many statements. Statements can be sequential, statements can be selective, means either one statement will execute either this or that out of two. That is selective block, that is conditional block. Or it can be repetitive. The statements can execute repetitively. All the statements can execute repetitively, or any out of two statements, one statement can execute repetitively. So in higher level, the program body, the statements which we put inside that function, those statements can be of sequential or selective or repetitive. So conditional is part of selective, means it will consider or not whether to statement to execute or not. In sequential, it will execute by default. In selective, it will, depending on the condition, it will choose whether to execute or whether to ignore. So we'll quickly see an example. If is a conditional execution, the syntax of if block is if followed by expression, any Boolean expression or logical expressions, which we just saw in our previous slide. Collection of Boolean expression through logical operators and or probably simple expression with not operator. Such things which turns out to be a true, that's part of condition expression. And after this expression, it has to be followed with colon. It is similar like the way we defined our user-defined function, right? So user-defined function usually will have parenthesis in C. In Python, it is not required. Just colon will tell that from there afterwards, whatever we write with 4 spaces is part of that block. With that block. Similarly, in conditional statements, if x is greater than 0, I want to I want to execute 4 to 5 statements, some 4 to 5 printf or some 4 to 5 calculations. If it is positive number, then only I want to calculate, say, instead of x, it is radius, I want to calculate circle. If x is length or breadth, I want to calculate the area of a rectangle and things like that. So if it is a positive value, I want to do so many things. That thing can be put under if with followed by 4 spaces, and that will indicates the compiler or probably the interpreter. In this case, it is an interpreter. So all the statements will be executed only if this condition is satisfied. So this colon will act as what all the following statements which are being encountered after this colon are part of if, provided if they are not having those 4 spaces. Quickly, if I want to write here, if we can write with parenthesis also, but without also it works. Similarly, for example, 10 is less than 12. Okay, and I'm just giving this example. If I enter, now I having a indented things, I will just say print and it say or single quote. Inside the selective block, it selected that statement to execute. And even I can write one more printf. But not printf, it is actually a print in Python. One more statement inside the selective block. What I'm trying to do is I can put as number of statements possible for this. Then how to come out? So I pressed double quotes twice there. There was a typo. Something is happening. We'll see that. Might be a yeah. So if I want to stop or don't want to add any more things, then if I press again one more enter, it will terminate. It tells the interpreter that that is the end of all the statements inside this conditional block. It is as similar as what we saw in the function too. So it as this is statements. In simple things, whatever the expression turns out to be true or false, if it is true, the statements belonging to this block will be executed. Otherwise, it will be skipped. Means if I given 10 is greater than 12, then definitely these two printf statement won't be executed at all. It will keep. So that is a condition part. The Boolean expression after if is called the condition. This is a condition or condition expression also we can say. It's an expression, right? It will be evaluated first to decide what the condition is all about. So this is a condition and it will be evaluated. So it's an expression. Expression is true, the indented statement runs, otherwise nothing happens. Means those statements will be skipped. They are bypassed. Okay. If statements have the same structure as function definition, that is with colon. I mentioned here colon. Even in our functions, user defined function def, function name within the parenthesis parameter list and colon. Right? Similar structure we saw in function also. A header followed by an indented body. This is part of header. After that header, what is the header now in this case? This is the header. After this header, the whole body is indented with 4 spaces. Statements like this is called compound statements. There is no limit on the number of statements that can appear in the body. This, as I said, I have wrote only 2 statements. The statements can be of print, it can be of input to read input from keyword, or it can be some more expression, or it can be condition also. It can be any valid statement where Python able to recognize. When I say valid, it has to follow some rules. For example, in the previous slide which I mentioned, this is not part of a valid operator in Python. If we give such operator equal to less than, equal to greater than, it will throw error. So any valid statement can be a part of if, and there is no limitation on the number of statements. Occasionally, it is useful to have a body with no statement. What do you mean by no statement? Means, for example, I'm writing a logic like if x value is greater than 0, then only you do this. Otherwise, if x value is 0, then don't do anything. In that case, you can just mention as pass. PASS is again a keyword, means of no statements. So simple example I have taken, if x is less than 0, pass. Else means x is definitely not less than 0, it is greater than 0 only. You do the other parts. So it's up to the programmer how we write usually, especially when it comes to condition. If the x value is greater than, then you do something. That something can be put at if side, and the if x value is less than 0, then you put that in else part, or you can ignore the else part. However, even we can do this if x is less than 0, means you put that condition in if part like this, which I just showed, and just pass if otherwise means else part. If it is x is greater than 0, you calculate all the possible formulas, like if x is being a radius, then the area of a square and things like that. This is the first form, very simple condition where just if I have shown. Now the second form is an alternative execution. In this case, if part, else part 2. Even at the end of else, colon is must. Same as if, colon is must. So syntax wise, students try to practice. Okay. In CT1, definitely it will be in offline, and there will be a lot of programs will be asked. to write simple programs without practice. If you make a simple mistake also, you won't be getting the marks, because if it is executable, then only you will eligible to get those marks, otherwise not. So reading, if you try to type few of the lines, you will, it is very much necessary for you to practice. Otherwise, you won't justify for this course. At the end of the course, you will be just having some documentation, where anyway you can get the documentation of Python online in detail. But however, this course helps you to solve the assignments, to give some exams, so that in that perspective you will explore more. All right. So practice whenever you get time. With respect to the alternative execution, if and else coming into picture, and uh, here it is either x is even is printed or x is odd is printed. That's why the alternative execution, or it can also, we can say, selective execution. It selects what needs to be executed, whether this to be executed, no, or this to be executed, no. So it's the next level of selection execution. Any one will be definitely printed. That is alternative execution. What is this logic is doing? Any value modulus 2, what it does, the remainder, if it is 0, then it is definitely an even number. If remainder is odd, then it is, if remainder is non-zero rather than odd, non-zero, it will be either what value? Remainder will be what at max? What are the possible remainder values for this? 0 or 1, right? 0 or 1. So if it is 0, then it is obviously even. If it is not, means that is, if it is 1, then it is odd. Students, any doubts till now? Okay. Showing. All right. So this is the more detailed explanation about what this simple piece of code is doing in with respect to Python. Exactly one of the alternatives will run, means either this or that. Now we have seen simple condition, alternative condition. Now it is chained condition. Chained means one after the for condition, even for else. Student, I am audible.
Yes, sir.
All right, and my screen is also visible to you all, right?
Yes, sir.
Okay. Suddenly I felt I logged out. All right. So the main difference I was talking about is with respect to C and Python, the colon thing is there and parentheses are not there. Instead of parentheses, indentation is coming into picture. Along with this, there is one more difference. There it is else if separate word, it is elif, but it is read as else if only. SE with space is been missed out. ELIF means multiple condition we can keep checking. X is less than Y, X is greater than Y, two conditions, it can be equal also, right? Of course, when these two are false, means this condition is false, this condition is false, then obviously it should be equal. So in that case, I can directly go and consider that it is equal rather than again checking. So three checks I can do here. So ELIF is an abbreviation of else if. Again, exactly one branch will run. One branch will be executed. It will check this condition is executed every time. When the previous expression is executed to false, then only it will execute it. Means if this is false, then this will be executed. If this is false, then only this will be executed. What if this is true? Then the statements under this block will be executed and this will never get executed. It will just skip it. So that is why it is selective structure. Selective structure. So we have seen the alternative execution as well as chained execution. Next is before going to that, before I think next is nested. Before going to the nested, there is one more simple thing which I want to explain. So again, I will take the reference of C programming. I think majority are comfortable with C. Whenever we write a condition block with multiple conditions, like if, else if, else if, else if. So after if there is at least one more condition to be checked using else if, then else is must in C, but in Python it is not necessary. For example, this is the valid example where I am checking whether the choice is a variable it can have any letter. It can have any letter. Right now consider it is Z. So Z is equal to letter A. No. So this won't be executed. Else if choice is equal to B. No, because it is Z. Else if choice is equal to C. Z is not equal to C, right? So this also turns out to be false. There is no else part, but still there is no problem in that. So Python gives bit flexible here. If the same condition or similar logic, if we try to implement in C, it throws error that else is missing. We have to mention the default path or default block. We have to mention there in C. But here it is not required. So if there is an else clause, it has to be at the end, but there doesn't have to be one. Else block is not necessarily should present. The syntax looks like this. All right. Each condition is checked in order. If the first is false, then only the next is checked and so on. Otherwise, if the first is true, then all the other conditions are ignored. Even though it is true, it might be true. If the first condition is true, that's over. It will execute the statements under that condition and rest of the conditions are ignored. If one of them is true, the corresponding branch runs and the statement ends. Okay. Even if more than one condition is true, only the first true branch runs. As I said, if choice is say no, in this case it is very difficult to match. Say any condition like if true, else if true, else if again true, something like that, and whichever leads to true, rest all even it is true, but it never gets executed. It will always execute the first true branch. First true branch. Now moving to the nested execution. We have under conditional checks, conditional execution till now, we understood about Boolean expressions, especially less than, equal to, greater than, less than or equal to, greater than or equal to, not equal to, that things, such expression turns out to be a Boolean output, true or false. And also we understood about logical operators to make two or more Boolean expressions concatenated with and or probably just a negate not operation. Such all operations can be put in simple if with just if or alternative execution if else. It can be chained execution if else if else if else if. I will keep saying else if because it is read as else if, but the actual keyword is elif, elif. So else if and followed by else. Else is an optional. You can keep and you may not keep. You can skip also. So next is nested. You have seen simple if, alternative, chained. Now it is nested. Nested means one inside the other. So the conditional blocks, if I keep one inside the other, it becomes a nested conditional execution. One conditional can be nested with another. We could have written this example in the previous section like this. If x equal to y, else. If it is not equal to means either it will be less than or equal to. Oh, sorry, less than or greater than, right? If x and y, two are the values, if they are not equal, then there's a equal amount of probability whether it can be less than or greater than, but we need to check. So inside else, again writing if else, this is allowed. This is allowed. The only main thing we need to take care in Python is this indentation. In the first printf, the indentation is 4 spaces. In the second printf, how many spaces? Can anyone tell? Of course, second and third print statements are having equal indentation, equal number of spaces left. Or right, Ganesh. So, first 4 is for this else part, and so even in ideally or probably in except the command prompt which I showed in the last class, like Python, here in this case I have to explicitly leave the indentation. N is less than 12. Okay, so it starts with if only. I have to explicitly give 4 spaces. So don't go with such tools. Okay, you try to avoid commands. Go with the environment where it automatically gives. For example, ideally, it's a shell. Inbuilt shell. When you're installing, you just option ID equal to 10. Okay, x and y case window. So if x is equal to y, then I will do something print equal. One simple thing. Then I will enter else part. I have to write else part. Something is happening. My program, something is set. Okay. Else part. This is the right way. Now it is y. I think I have got refreshed. Students able to see my screen? I hope all the students are able to see my screen. Hello? Am I audible, students? All right, okay. And I hope you guys are able to see screen also. So what I was explaining here, so before writing print, I just enter right. So automatically my cursor comes to the next four indentation space. First four is for the else part, the first else part, and the next four is for this if part. Print equal, I will say x is lesser. X is lesser, simple. And else, oh, entered, I missed what I missed? Colon part I missed. So colon is must. So what I'm trying to explain here is the indentations are automatic in the IDE, the integrated development environment. So there are so many development environments. You can make use of any environment. There the indentation is automatic. The only thing you have to make sure this statement is part of the outside if or inside if, that thing, whether this printf is outside else or is part of inside if, that thing you have to take care, but automatically it does the indentation. All right, so that's the one thing. So this is a classic example. So time is 2:20. I will stop here. Okay, so I will stop for today, and I will resume in the next class. Aradhana, please hope I